Okay, today we'll start with a new types of differential equation, exact differential equations of first order. The differential equation which can be written as a form m dx plus n dy equals to 0 is called exact differential equation. We have already known it. Now today we'll start with exact differential equations. Actually there will be two parts. One is m is the function of xy, and another function n xy, and if we can arrange the differential equation like this m dx plus n dy equals to 0, then the form of differential equation will be exact. Okay, the exact differential equation, what will be the actually a differential equation m dx plus n dy be an exact differential equation in region R of the xy plane, because there is a two variables, one is x and other is y, xy variables, if they corresponds to the differential of the same function f of xy defined in region R, a first order of differential equation can be written as the form, previous form m dx plus n dy equals to 0 is said to be an exact if the expression on the left hand side is an exact differential equation. Okay, actually there is a theorem for exact differential equation. We have already known that the theorem will be if the differential equation can be arranged in such a way that m dx plus n dy equals to 0, and if we differentiate partial differentiation del m del y equals to del n del x, is this two partial differential equation will be equal, then the equation is said to be exact. This is the actually main condition criterion for the exact differential equation, del m del y equals to del n del x. Actually partial differentiation of m with respect to y equals to partial differentiation of n with respect to x will be equal. If this is equal, then this differential equation is said to be exact differential equation. Now actually what will be the definition of exact differential equation? A differential equation is said to be exact if it can be obtained from its solution of the form f of xy equals to c. That means the solution can be written as curve curve of two-dimensional xy, and directly by differentiating and without any further process of elimination, such as this equals to c is an exact differential equation, its solution will be this. Just this will be the according to the definition, this will be the exact differential equation, and it will be the solution. If we differentiate equation 2, this is the equation number 2, if we differentiate this solution, we get the original differential equation, we get the back the equation 1 directly. That means the solution will be the differential equation, that will be solution. If we differentiate the solution, then we can get back to the original equation, which will be the differential equation, and this will be the exact differential equation. Actually there is a theorem for this. If we can write any differential equation m dx plus n dy, then this will be exact if del m del y equals to del n del x. This partial differentiation will be equals del m del y equals to del n del x. Just taking two partial differentiation, del f we get this equal actually. Now how we can solve the exact differential equation? Suppose there is a given differential equation x square minus 2x xy plus 3y square dx plus 4y cube plus 6xy minus x square dy. This is the actually exact differential equation. Suppose m equals to this and n equals to this, because this look like this m dx plus n dy. So m will be what? Just coefficient of dx, and n will be the coefficient of dy. So taking partial differentiation of m with respect to y, del m del y. If we take the partial differentiation with respect to y, x will be treated as constant. Okay, then we get minus twice x plus 6y, and this also equal. So this del m del y equals to what? Del n del x. So we can take a decision that what will be the given differential equation is exact, because this is equal in this given differential equation. So we can say that this is exact differential equation. Now integrating m with respect to this, because this is the actually procedure to how to solve differential equation. There is a m, actually this is the given m in differential equation. We have to differentiate, we have to integrate this m with respect to x, keeping y as constant. Okay, just this is the m. Now we have to integrate it with respect to x, keeping y as constant. That means what will be, this is the integration with respect to x will be this. Okay, x square integration, what will be, x to the power 2 plus 1 divided by 2 plus 1, that means x cube by 3. This will be x square y, and this will be constant, so only one integration, what will be, x. Now in n, observe in n, free from x, free term of with x, which one? Actually 4y cube, there is no x. That means without x term will be the we have to take n. In n, free from x, in n free from x, what? 4y cube. Now we have to integrate it with respect to y, integrate it with respect to y. Integration of this, what will be, y to the power 3 plus 1 divided by 3 plus 1, that means y4 by 4, 4 will be cut, so only y4 will be the result. Now the required solution will be sum of these two integration, this sum this of this equals to c. This is the actually solution of the differential equation. Understand? Just taking sum of this two integration. Actually, we have already known that exact equation, that means exact differential equation, and with the integrating factors. We must know the ordinary differential equation can be arranged like this: m plus n dy dx. Actually y dash means what? Dy dx, first differentiation of y with respect to x. You can write also m dx plus n dy also. Suppose there is another function psi. This is the another function psi x. This is the partial differentiation of xy. Okay, and psi y, partial differentiation of y with respect to y. This is the n, this is the mxy, mx, and this is the n. So you can take this, just taking integration constant y equal to 5x. So that means this whole function can be written as ddx of this. So this is differential equation is actually exact. Okay, so suppose differential equation can be written as like this: m dx plus n dy equals to 0. That means m plus n dy dx. Y dash means dy dx. So if we take m, n, my, and x, actually my means what? Partial differentiation of y of m with respect to y, and nx, what will be? Partial differentiation of n with respect to x. Same words. And these four all are containing in the rectangular region R. That means xy plane. Xy means plane what? First quadrant, x-axis and y-axis along y-axis. Then equation 1 is exact differential equation if these two are same. That means del m del y equals to del n del x. That means partial differentiation of y with respect partial differentiation of m with respect to y equals to partial differentiation of n with respect to x will be equal in the same region xy plane. Okay, that means this, if this condition is satisfied by this differential equation, then this differential equation is called exact differential equation. Now consider another following differential equation: dy dx will be this. That means this can be written as m plus n dy dx. That means m dx plus n dy, where m is equals to what? M equals to what? X plus 4y, and n equals to what? 4x minus y. Just taking partial differentiation with respect to y, partial differentiation with respect to x plus 4y, what will be? The x will be constant, this is why 0. Partial differentiation, this is why now y differentiation what 1. This is why only 4. Now again taking partial differentiation of n with respect to x, mane del n del x, what will be 4 into x differentiation what 1, and y differentiation what will be partially 0. This is why only 4. So that since these two are equal, these were mdx plus ndy and del m del y equal to del n del x. This two partial differentiation is equal to 4. This is why the ordinary differential equation, that means given the ordinary differential equation of first order, is exact according to the previous example and according to our definitions. Solve kore. Now actually directional field and solution curve. Actually after solving exact differential equation, we have to indicate the curve of solution. Then we must know about directional field and solution curve. Our differential equation and solutions are given by dy dx. This equals to what? X square plus 8xy minus y square. This was the actually solution of our previous example, right? This was the solution, right? Just taking integration of m with respect to y and in n without x, without the term x, then integrating. So this will be the solution of our previous examples. So now we can indicate the solution in graph in the xy plane. This is the x axis and this is the y axis. So this is will be the xy plane. Now a graph of the direction field for this differential equation along the several solution curves is given. Actually there are, for different values of c we get different curves. Okay, and for because the dy dx is the actually what rate of change of y with respect to x. So for every point there is a actually direction. This is why there are more and more direction, because there are how many curves? 1 2 3 4 5 curves for different values of c. For there is a dependent variable y and independent variable x. For different values of x and y we get this curve of the solution. Now this solution actually can be actually this is a function and the solution is defined implicitly by our equation. Implicitly means actually mixed with x and y. Okay, these types of equation is called actually implicit equation. Explicit equation, you must know about this, implicit and explicit. So in this case we can solve the differential equation directly. How? If we solve look like a quadratic equation, x square plus bx plus c types, taking y as a variable and x other are constant. That means y is taking y as a variable, y square minus 8x minus x minus c equals to what? 0. This equation can be written as like this. This is actually look like quadratic equation, x square plus bx plus c, and here y is the variable and all are constant, seems to be constant. So this solution can be written as y equals to 4x plus minus square root 17x square plus c. Actually what's from where this comes? By solving quadratic equation x square plus bx x plus c equals to 0, we can write x equals to minus b plus minus square root b square minus 4ac divided by twice a, where a is the constant, this term. Okay, and b equals to what? Coefficient of y. Coefficient of y what? Minus 8x. Okay, and a equals to what? 1 only. That means this is the quadratic in y. Then solving for y equals to this. For different values of x and c, okay, this is the constant term, we get different values of y. So solution curves for several values of c we can indicate this. Actually this is the hyperbolic, and this is also, and this is also for different values of c. Okay, you can use different software like MATLAB or other software. You as you engineering student, you are an engineering student, you can apply this, you can solve different values of c. Okay, y equals to this, and you can show this in graph. Okay, this is the solution curve for this differential equation. You can use different types of tools, programming tools for this. Now consider the following differential equation. This is also can be solved with the help of previous example, like this. Here m equals to this part and n equals to what, this part. Thus taking del m del y, that means what, partial differentiation of m with respect to y, and this will be the partial differentiation of n with respect to x. Actually these are two equals, so it can be said that actually it is what, exact differential equation, because these are equal. Now we can solve this exact differential equation. We can integrate m with respect to what, with respect to x. We can integrate it with respect to x, then keeping y as constant, remember it. And in n, free from x, what, this is x, and this is the x term, and free only this. So integrating this with respect to y, what will be, only y. Okay, so the required solution will be what, y sin x plus x square e to the power y minus y. Actually they have applied the previous theorem, just we are considering this as our previous example, first example. Y sin x plus x square e to the power y, this is the actually solution of this differential, exact differential equation. Now actually we can indicate directional field and solution curve for this differential equation. After solving this differential equation, this is the solution. Okay, a graph of the directional field for this differential equation along the several solutions can be found like this. This is actually xy plane, in xy plane for different values of y, and this is the transcendental equation, because sin x is present here, sine curve. So for different values of x, we get different values of y. Okay? By solving with programming tool, we get this. You can use MATLAB for this. I will supply you the code for this, then you can solve it. Okay, this is the actually exact differential equation, and how to solve exact differential equation, and how to indicate the directional field and solution of the curve of exact differential equation in xy plane, that means in the graph. Now actually how to solve the initial value problem, obviously exact differential equation, and this is the exact differential equation. We will test it whether it is exact or not. Now how to solve the initial value problem of differential equation, first order ordinary differential equation in exact differential equation. How to solve initial value problem, we will try to understand this. Actually this is the given initial value problem. Actually initial value problem, what, for initial value of x, actually x equals to 0, and then we get y0 equals to what, 1. There are two values given, one is dependent variable values and other is independent variable values. Independent variable values, what, x equals to what, 0. For x equals to 0, y equals to what, 1. This condition is actually initial for what, actually initial value of independent variable is given. This is why it is called initial value problem. So now consider this is actually with respect to time. There is a independent variable, what, independent variable, what, please tell, independent variable, what, here, t. In replace of x there is present what, t. That means in independent variable t and dependent variable, what, y. That means dy dt. This is not dy dx. So the given equation can be written as m dt and dy. That means m dx plus n dy. Look like this as our previous example. Now which has the form mty mxy. This is the function. M is the function of what, not xy. This will be what, ty, because independent variable here t. So m dt, and this will be actually n, not not m, this will be n. That means mdt plus n look like what, mdx plus ndy equals to 0. We have arranged this the given differential equation, and here m equals to what, this m equals to what will be just coefficient of dt, and what will be coefficient of dy. This is the actually dy. Now taking partial differentiation of m with respect to what, y. Partial differentiation of taking m with respect to what, y. So we can take partial differentiation. Actually t will be the constant when we will partially differentiate m with respect to y. T will be what, constant. So e to the power twice t, this is the constant. So y differentiation what, 1. This y 2 et, and 2t is the actually constant, and cos y differentiation what, minus sign y. Okay, so this is the actually partial differentiation of m with respect to y. Now again taking differentiation of n with respect to t, what will be, taking integration, taking differentiation, partial differentiation. Here y will be the constant, okay, t will be the variable. So taking partial differentiation of n with respect to t, 2 into e to the power twice t, what, e to the power x, formula e to the power x, but we have to multiply with the coefficient of what, t coefficient what, only 2. This way multiplying with 2. Now t square in differentiation what will be, minus twice t, and sin y will be constant, because this is the partial differentiation with respect to t. Since del m del y equals to del n del t, this becomes equal according to the theorem of exactness. These two are same, these two partial differentiation are same, so the given differential equation is exact. Now integrating m with respect to t, keeping y as constant, look like before statement, our first example. So integrating m with respect to t with respect to t and keeping y as constant, that means integration of this what will be, just taking integration, y will be constant, twice y will be constant. So e to the power twice t integration what will be, e to the power twice t, but we have to divide with the coefficient of t. In integration we have to divide with the coefficient of t. Coefficient of t what, 2. 2 divided by 2 will be cancelled. Now here we have to integrate the with respect to y, t. So cos twice t what will be, twice t integration what will be, twice t integration what will be, please tell. T square by 2, t square by 2, that means t square by 2 what will be, t square by 2, 2 will be cancelled, this will be only what, this will be only t square, understand, 2 will be cancelled, and this will be only cos y, so this will be only this is because keeping y as constant, this is why. Now again n free from t, is there any variable free from t in n? This is the n free from t, there is no variable, so free from variable what, so free from variable only 0, this constant only c1, just only taking c1 constant. So this integration of mty dt plus just taking integration of m with respect to t, keeping y as constant, plus integration of n without containing t dy equals to 0. This is the actually solution of exact differential equation. Now this will be twice t, this will be what, cos, not sine, remember it, there is a mistake, cos. This is the actually solution of this our previous differential equation. Now imposing initial conditions, y 0 equals to 0, at t equals to 0 y equals to 1, right, at t equals to 0 y equals to 1. So from this solution to what will be, 1 into e to the power twice 0, 2 into, this will be not 2, this will be t square, right, this will be t square. Actually try it at home, and you can do, and this will be t square. Okay, t square. So t square, and this will be cos. So after putting t equals to 0 and y equals to 1 here, okay, we get what? C equals to 1. So the required particular solution can be written as just putting c equals to 1 here. Okay, just we get this required solution. This will be the actually required solution of given exact differential equation. Okay, what will be the solution actually? Y into e to the power twice t plus t square plus y equals to 1. Just putting c. There is without constant. This is actually particular solution. Remember it. There are three types of solution. One is singular solution. From our first lecture, we must know about the solution of differential equation. One is singular solution. Other is particular solution, and another is what? Another solution what? Singular solution, particular solution, general solution. Okay, containing c. If you can find out any solution containing c, this will be the what? General solution. But after imposing initial conditions, we can substitute constant this. Okay, substituting this constant, we get this is the required equation, and this is called particular solution. Now we can solve another initial value problem for exact differential equation. This is also independent variable t and dependent variable y, and these values are given imposing initial values x equals 5 and y equals to what? 0. The given equation can be written as like this. Okay, now which has the form what? Mty dt plus mty dy equals to 0. Now where m equals to is first what? Coefficient of dt, and equals to what? Coefficient of dy. So del m del y equals to what will be? Just taking partial differentiation of m with respect to y. Okay, y will be with respect to y will be 1 by t, and this will be 0 because t is the constant for partially differentiation of m with respect to y. Now taking similarly differentiation, taking a partial differentiation of n with respect to t will be what? 1 by t. Okay, this will be 0. Since del m del y equals to del n del t, that means these two, according to the theorem, this equals to 0. So the given differential equation is exact. Now we'll solve this. Now integrating m with respect to what? T, keeping y as constant, then we get this. Okay, just integrating with respect to t minus y by t square, and cos t will be sin t. Again, in n free from t, what will be? E to the power y. Okay, in n free from t, but only to the power y. So integrating this with respect to y, what will be the result? E to the y plus sigma. Okay, so the solution of the given exact differential equation will be integration of m with respect to t keeping y as constant plus integration of the term in n without containing t with respect to what? dy equals to c. Just taking the sum of these two equals to c. Now using initial conditions for x equals for t equals to pi, y equals to what will be? 0. This is the given initial condition. So from equation 2, just putting t equals to pi. Okay, t equals to pi and y equals to what? 0. We get c equals to what? Only 1. E to the power 0 means 1. Sin pi equals to 0. Remember it. These two term will be 0. So only c equals to 1. So hence the required particular solution of this given differential equation, exact differential equation of this will be this. Okay. Now you will try it at home. This is the from book of Dennis Zill. I will give you this book, maybe given in Google Classroom. You will try it at home. 3, 4, 5. Okay, this 3 will be homework for you. Now how to solve this differential equation? Now here we can arrange this mdx plus ndy equals to 0. Look like mdx plus ndy equals to 0. Here m equals to what? Twice xy cos x square minus 2xy. Okay, plus 1. And here n equals to what? Sin x square minus x square plus 3. Now taking partial differentiation of m with respect to y, we get this. Keeping x is constant. Similarly, del and del x will be this. Okay. Now this two partial differentiation is equal here. Del m del y equals to what? Del n del x. So the given differential equation is exact differential equation, right? Now the solution of this differential equation will be integration of m with respect to x keeping y as constant plus integration of term of n not containing x. Okay, that means term without x equals to c. Now just integration of m equals to this. Okay, now term n not containing x, what will be actually? Only 3, right? Only 3. Just taking integration of 3 with respect to y. Just taking this integration, we get this. Now to solve, we have to put x square equals to t here. Then twice x will be substituted. Okay, twice x dx will be substituted by dt. Then this is actually required general solution. This is not particular solution because c is unknown for us. C is the constant and this constant unknown to us. Okay, understand everybody? Hello. Clear? Now another example for you. 1 plus e to the power x by y plus e to the power x by y 1 minus x by y dy dx equals to 0. Now we can write this given differential equation like this: m dx plus n dy equals to 0. Multiplying dx on both sides. Okay, so we get m dx plus n dy equals to 0. Here m equals to this. Okay, m will be that of what? Dx, and taking partial differentiation with respect to y will be this. 1 will be 0. 1 will be what? With respect to y will be 0 and e to the power x by e to the power x formula e to the power x, but 1 by y integration what will be? 1 by y integration minus 1 by y square. 1 by x integration what? 1 by x differentiation what? Minus 1 by x square. This y with respect to y minus x by y square. And in and will be this. Just taking partial differentiation of n with respect to x will be this. So del m del y equals to del n del x. We get this as equals to equal. So the given equation is exact. Now its solution will be integration of m with respect to x and integration of the term n containing not x, that is not containing x without x. Dy will be equals to 0 equals to c. So this integrating with respect to x will be this. Understand everybody? Very easy for you. Okay, equations reducible to the exact differential equation. Sometimes differential equation which is not exact may become so on multiplication by a switchable function known as integrating factor. Then we have to take the help from integrating factor. Okay, there are actually two rules that first rule is if it is not exact, that means del m del y equals to not equal to del n del x. Then we have we can apply first rule. Rule 1 will be if del m del y minus del n del x divided by n is a function of x alone. If we get after dividing this with n, we get the function of x alone, then that means f of x only, y absent. So integrating factor what will be e to the power integration only that function only after getting this function, that means f of x. Okay, now example for this. Suppose this is our given differential equation, and here m equals to twice y, m equals to what was twice y, m dx plus n dy, actually in reverse order, m dx plus n dy, right? This is then so n equals to this. Now taking partial differentiation of y with respect to partial differentiation of m with respect to y will be only 2. Y integration differentiation will be 1. So, and here del and del x what will be? Partial differentiation of x with respect to n will be 2 into 1 plus x minus y, x log x, uv process, u into b differentiation plus b into u differentiation, remember it. Y constant, this is y, only x differentiation 1 y, because del m del y and del n del x are not equal, so it is not exact. Understand? So you have to reduce it to exact form. How will we reduce it? Suppose del m del y minus del n del x divided by n, what will be? We have to test first. Just taking subtraction, del m del y minus del n del x divided by n. N means what? This 2 del m del y what? Only 2, and del n del x what will be? This whole, taking minus. Now n what? N will be this. Now 2 cancel, just a minus, we get this, and 2 log x minus y, 2 log x minus y will be cancelled. Minus 1 by x. This is the function of x only. Okay, this is the function of x alone. Remember it. Rule what? Is a function of x alone. This is why minus 1 by x will be f of x. Now integrating factor what will be? Actually integrating factor, integration of f of x means what? Just minus this value minus 1 by x. Integration what will be? 1 by x formula for what? Integration log x, and minus 1 will be comes to the power of x to the power minus 1. E log will be what? Cancelled according to the properties of an exponential function. So x to the minus 1 by y, x is the only integrating factor. Now multiplying the given differential equation 1 by x, just multiplying 1 by x on both sides, this will become exact differential equation. Understand? And since this is the exact differential equation, so integrating m with respect to what? X, and without x in n, what will be? Only minus y. Okay, only minus y integrating with respect to y, we get this is the actually general solution of the given non-exact differential equation. This was non-exact. Okay, after multiplying this integrating factor, it becomes exact differential equation. Now you can take this is m and this is n, del m del y equals to del m del x will be equal. So integrating m with respect to x, and in n without free from x will be this, and integrating this will be with respect to y. So this sum will be the constant, and this will be the solution of the given non-exact differential equation. Similarly, for rule 2, we can solve this differential equation using this rule. Okay, first rule. Now second rule, if del n del x minus del m del y, okay, if we subtract del m del y from del n del x divided by m is a function of y alone. Okay, remember it. This will give function of y. Then integrating factor what will be? To the power f of y dy. Now let us study another example. Like this, y to the power 4 plus twice y dx, that is dx plus n y equals to 0. Here m equals to this, and n equals to what will be? Just coefficient of dy. Now taking differentiation of partial differentiation of y of m with respect to y, del m del y what will be? This. Okay, and then del x what will be? Taking partial differentiation of x with respect to, so taking partial differentiation of n with respect to x, what will be? Y cube minus only 4. This will be 0. Now taking this, adjusting this rule 2, del n del s minus del m del y divided by m will be actually function of y minus 3 by y. Okay, so integrating factor what will be? To the power function of y dy with respect to y, remember it. So minus 1 by y integration what will be? 1 by y, 1 by x formula what? Minus 1 by y what will be formula? y to the power minus 1 formula. Okay, y to the power minus 1 what? Minus 1 into y to the power minus 1 minus 1. 1 by x formula what actually in integration log x. 1 by x formula what? Log x. This is why we can write e to the power log y to the power minus 3 y to the power minus 3, that means 1 by y cube. Now multiplying 1 by y cube on both sides of given differential equation, then it will become exact differential equation. Then now integrating m with respect to x, keeping y as constant, and in n free from x what? Only twice y. Okay, just integrating this with respect to y, will this sum will be equal to the c, and this after taking integration we will get this whole will as a solution of this given differential equation. Now adjusting this rule 2, you can solve this. Okay, understand everybody? Now for rule 3, if m is the form of this, then we can take integration in integrating factor as 1 by mx minus ny. Okay, if m is the form of y into f1 f of xy and n is the form of x into f of xy, then we can take integrating factor as 1 by mx minus ny. This is actually rule 3 for solving non-exact differential equation of first order. Now how to solve this? Actually y into this dx plus x into this equals to y. Actually y into what? F of xy, this is the first function, and this is the n, actually x into n. Here y into this, we can write this given differential equation like this. Okay, just dividing by 1 by xy, given differential equation, and dividing by xy, we get y into 1 plus twice xy and x into this. Here m equals to what? Y into a first function and n into second, x into second function. Now integrating factor what will be? 1 by mx minus ny equals to 1 divided by xy bracket 1 plus twice xy minus xy bracket 1 minus xy. Just m into x, okay, and n into y. N means this. F2 means what? This 1 minus xy. And F1 function what? 1 plus twice xy. Just adjusting with the third rule, integrating factor what will be? Actually 1 by 3x square y square. Now multiplying this to the given differential equation 2. Okay, we get this. This is the m and this is the n. Now integrating m with respect to x, we get this, and free from x into n what? Minus 1 by 3y. There is not free from x, this term. Only free from free term is of x, but minus 1 by 3y. Now integrating this with respect to y, taking sum of this equal to c. This will be actually general solution of the non-exact differential equation. We can also solve this 4 by this method. Okay, now we can solve actually many types of differential equation like this. Another example for you: y into 1 minus xy dx minus x into 1 plus xy dy. Okay, here m equals to what? Coefficient of m dx plus n dy equals to 0. Actually m dx plus n dy not equal to 0 here. Okay, so m equals to this and n equals to this. So mx minus ny what will be? Y is xy. Okay, so this taking this subtraction. Now integrating factor what will be? 1 divided by mx minus ny, that is 1 divided by y is xy. Multiplying this with the given differential equation, we get this. Understand everybody? Just multiplying. Okay, then we get just taking 1 by x and x will be 1, this by only y, and 1 by y, this y cut only x. Here m equals to this and n equals to this, and taking the integration partial differentiation of m with respect to y, del m del y equals what? Minus 1. This will be constant. Then now taking partial differentiation of n with respect to x will be what? Only minus 1. Okay, this minus before bracket. So this is equal. Now this becomes exact differential equation by using third rule. Okay, third rule. Now the differential equation will be exact and its solution will be integration of m with respect to x, and in n free from x, what in n free from x will be 1 minus 1 by y. So just taking integration, sum of this integration equals to c, we get this. This is actually required general solution. Now there will be 1 by x formula log x, and this will be minus only this, and this will be only log y. So taking log y and log x in a body, log x by y minus xy log c, taking log c as a constant, log c we can take also. Now this xy can be written as log e to the power xy. Okay, log e to the power xy. Now this 2 log, taking sum log c into sum, for sum will be multiplied c into e to the power xy. So x divided by y equals to c into e to the power x by y. So x equals to what will be? This is the actually general solution. Similar process we can proceed for this differential equation. Actually every maths are same for you. This we have studied this example, and you can apply. Actually we have applied this necessary and sufficient condition to find the necessary and sufficient condition for a differential equation of first degree being exact. Actually this is the del m equal del m by del y equals to del n by del x is the main sufficient condition for this. Actually we have applied this in our example. Now we'll study some application of differential equation in engineering, actually in your area. Please concentrate now. We will try to discuss about the differential equation in application engineering especially. Actually first engineering application problem. RL circuit with ramp input. Recall from the standard ramp function has the value t is the time will be less than 0 and a value ct for t is greater than 0. This figure actually a voltage ramp signal with a value c equals to 1 is applied to RL circuits. I will give you this lecture sheet to you. The arrangement is shown in figure 19.4. This is the actually circuit figure. The differential equation governing the current flow IT, current flow, actually current I at time t. Okay, in the circuit is given by this. This